Hi guys, welcome to math class. Today we're going to be doing pages 8 through 10, so make sure you have your packet ready. And you can have your calculator with you if you would like. I started doing some work, so I'm just going to quickly erase this so I can start with you from the beginning. Hope everything is going well, that you're enjoying this time spent with your families. Okay, so the first thing that we're going to do is we're going to use the given information to find the value of k and also the second root. So if 4 is a root, that means that 4 works in this equation. So I'm going to start by substituting in 4. So that gives me 16 minus 28 plus k equals 0. 16 minus 28 is negative 12. The opposite of subtracting 12 is adding 12, so therefore k equals 12. Now that I know k, I'm going to substitute that into the equation. So remember, this is a quadratic equation. So every quadratic will have 2 answers. So I have one answer, the one answer of 4, and I'm looking for the second answer. So I'm plugging in 12 where k previously was, and I'm going to factor this. So I do have a hint, since 4 is one of the roots, I do know there's going to definitely be a 4. 4 times 3 is 12, so the other one is a 3, and they're both negative. If I solve this, I get k minus 4 equal to 0, which means k is 4. And that can also serve as a check because I knew that one of the roots was 4. I have k minus 3 equals 0, so k equals 3, and that would be the second root. I don't know why I changed these to k's. They should have all been x's. Sorry about that, guys. These should all be x's. I guess I had k on my mind. All right, so let's do the next one. So they're telling me that one of the roots is negative 4. When you're working with negative numbers, it's really important to use parentheses because negative 4 squared is different than the negative of 4 squared. Negative 4 squared is negative 4 times negative 4. So that's a positive 16. Gosh, I keep making mistakes, guys. Sorry. Minus 24 plus k equals 0. 16 minus 24 is negative 8. Negative 8 plus k equals 0, so k equals 8. So I'm going to substitute that in to find the other root. I have x squared plus 6x plus 8 equals 0. I factor that. I get x with a 4 and x with a 2. 4 times 2 is 8, and 4 plus 2 is 6. So this works out because if I have x plus 4 equals 0, I do get x equals negative 4. Checks that. X plus 2 equals 0. I get x equals negative 2, and that's the other root. Okay? Again, when there's context, if there's a story with this, if there's some kind of application, sometimes both answers aren't correct to be used. They're still answers, they're still viable answers, but they're just not useful in that situation. We haven't done anything with context yet, so we're accepting all answers. All right, so 2 is a root, so I'm going to plug in 2. Again, I'm solving for k. You can solve any equation for an unknown as long as there's only one unknown. If there's 2 unknowns, you need 2 equations. So that gives me 16 plus k equals 0. So k equals negative 16. I'm going to use that to find the second root. Okay, so I know one of the roots is 2, so I know that's going to be an x minus 2. If you think about working backwards, if x equals 2, what had to be above that? So sometimes you can use working backwards as a benefit. The other factor is going to be x plus 8. So if I have x minus 2 equals 0, x does equal 2, again, serves as a check. And then if x plus 8 equals 0, x will equal negative 8. So the other root is negative 8. Okay? this is really just taking some things we already know. A root is known as a solution. They basically use three names for these roots, solutions, or zeros. Okay, zeros comes from the fact that it's that number times 0 equals 0. So since everything is set equal to 0, we sometimes call the solutions zeros. All right, today we're going to look at incomplete quadratics. An incomplete quadratic is when you're missing either the linear term or the constant term, and sometimes both. Okay, so if I'm looking just at standard form, and I know that the constant term is missing, if the constant term is missing, that means the constant term was actually a 0. If you don't see the constant term is 0. If the linear term is missing, that means that the coefficient of the linear term was 0. The coefficient of the linear term was 0. If they're both missing, which doesn't usually happen, but if they're both missing, that means that the coefficient of the linear term was 0 and the constant was 0. And that just basically means that x squared equals 0. Okay. So we're going to look at these, and we're going to just solve them a little bit differently than we were the past couple days with basic trinomial factoring. The basic trinomial factoring is when you are saying, I'm looking for two numbers that have a product of this, yet add to that. In this case, we're going to be doing a little bit more GCF factoring. Okay, so again, you always want to start by rewriting it. I put the 0 on the left. You don't have to have it on the left. It could be on the right, but I think you'll see it on the left more often. And you just want to develop your own habit. When things become habit, they just are part of natural how you do something. And the more that you make your math seem like it's natural to you and that you're almost not thinking about what you're doing, you're just doing it automatically, it shows that you're understanding what you're doing. So, all right, so here, I happen to have the constant term missing. And we're going to see when the constant term is missing, GCF factoring is really a good go-to. So I'm going to do GCF factoring. That means I'm going to pull out a 4x because 4x is the GCF. And that gives me x plus 2 as my other factor. So now I have it factored. I'm going to set both factors equal to 0. Divide by 4, and x equals 0. Subtract 2, so x equals -2. When the constant term is missing, you're going to always have one solution that is 0. When the constant term is missing, you know that one of your solutions is 0. Okay, so for this one, I'm going to do something a little different than I had been. I'm going to take the 36 and actually move it to the other side. This is isolating the quadratic term. When there is no linear term, this works out really well. Or you could think of it as the difference of two squares, which you're familiar with as well. I'm going to divide by 9. That gives me x squared equals 4. And then I'm going to take the square root of both sides. So that gives me x is equal to plus or minus 2. It is really important that you put both the positive sign and the negative sign. In the past, we've used only the principal square root, which is the positive square root. But with quadratics, you want to make sure that you're using both. Okay? If you don't like the way that's written, you can just write it out the way you're used to. Okay, for those of you that don't like this, you could have done the difference of two squares. That would have been 3x minus 6, 3x plus 6. Set those equal to 0, or pull out the GCF of 9 And then you would have had 9 times x minus 2, x plus 2. However you want to get it done is fine. I'm just going to show you some different ways today. All right, so now we're on the practice. So my recommendation to you is that if the constant term is missing, look for a GCF. So if you think back, don't remember what day it was that we did it, but if you have only 2 terms, it's a binomial. And with binomials, you only have 2 choices. You have GCF factoring or difference of 2 squares. So this is kind of review of that, and I'll try to do them different ways. But if the constant term is missing, GCF's your only alternative. So I'm going to pull out the GCF of x. It's factored. I set those factors equal to 0. So I have x equals 6 and x equals 0. Sometimes you'll also see it written like as a little set. Now, we haven't done any checks, but you can check these by substitution. So if you just check it mentally, plug in a 0, 0 squared minus 6 times 0, that equals 0. And plug in the 6. 6 squared, 36. 6 times 6, 36. 36 minus 36, 0. Solutions work. That's why they're called solutions. All right, so here we go. I'm going to move the quadratic term to be together. So what I'm going to do is subtract the x squared. That gives me 3x squared. But I'm also going to add the 27 equals 27. I'm going to divide by 3. That gives me x squared equals 9. And then take the square root of both sides. So that gives me x equals positive 3 and negative 3, plus or minus 3. Again, if you don't like this method, you can use difference of 2 squares. I'll show you difference of 2 squares on the next one. So I could divide by 4, and do square root, but I'm going to do this using difference of 2 squares just to show you another way. Okay, so the first term is a perfect square because 4 is a perfect square, and any variable with an even exponent is a perfect square. So x squared, x to the 4th, x to the 6th, etc. Okay, so the difference of 2 squares, I'm going to do my double set of parentheses. Square root of 4 is 2. Square root of x squared is x. And the square root of 49 is 7. So I have 7, 7, 1's a plus, and 1's a minus. Set those factors equal to 0. I have 2x plus 7 equals 0. So 2x equals negative 7. So x equals negative 7 divided by 2. 2x minus 7 equals 0. So 2x equals 7. X equals 7 divided by 2. Again, you'll notice that those are opposites, additive inverses, which is what you always get with the difference of 2 squares. Okay, so for my next one, I'm going to set it equal to 0. I moved the 8x by subtracting. The GCF is x. And I set my factors equal to 0. So x equals 0, x minus 8 equals 0. The opposite of subtracting is adding, so x equals 8. When the constant term is missing, then you're going to have one of the solutions 0. When the constant term is missing, one of the solutions is 0. All right, here we go. 2 more. Maybe it would be a good time for you to pause and try these on your own and then start the video again to see if you understand what I'm doing. This is factoring. I know everyone thinks like GCF factoring is not factoring, but it's GCF. Greatest common factor, that's factoring. It's not the double set of parentheses, so it does look a little different, but it's still factoring. All right, the GCF is X. Set the factors equal to 0. Also keep in mind, once you set your factors equal to 0, the hardest it's ever going to be is a two-step. It's never going to be harder than that. And you can all do two steps. You just have to be careful of your signs. Okay, so 2x is equal to 5. Divide by 2, I get 5/2. If you don't like fractions, go decimal. It's fine. It's whatever you're happy with. Okay. GCF is X. So I get 5x plus 6. Set each factor equal to 0. Opposite of adding is subtracting. Opposite of multiplying is dividing. Those are my solutions. All right, I think this is the last one. Is it? Yep, appears to be. Okay, so this one has a little more work. I'm kind of getting bored of this red. I'm going to purple. Okay, so that's 5x squared. Remember that when you multiply variables, you have to have like variables, and then you add the exponents. If they're not like, you just write them next to each other. Like x times y is just xy. All right, minus 30x minus 8x equals 2x. I'm going to put all that together. So I have 5x squared minus 38x equals 2x. Subtract the 2x. 5x squared minus 40x equals 0. Factor out of 5x. So x subtract 8 equals 0. Set those factors equal to 0. So notice it's still x equals 0. If the constant term is missing, one of the solutions is always 0. And then I have x equals 8. So my answers, and don't forget 0 is an answer. I know sometimes we discard 0 because it doesn't have value, but it has meaning. So 0 and 8, if I plug in a 0, it'll hold true. If I plug in an 8, it'll hold true. Those are the solutions. Okay. Basically, that's all for today. I'm going to make this screen smaller so we can see the whole screen at the same time. And, this way, if you want to screenshot it, you can. I'm going to take a second and make sure I didn't make any mistakes because when I started today, I wasn't doing so well. So I have 0, 6, positive 3 and negative 3, positive 7/2 and negative 7/2, 0 and 8, 0 and 5/2, 0 and negative 6/5, and 0 and 8. So yay for me. Got that page right. I hope you understood today's lesson. Again, it's really not anything new. It's just practicing and looking at some quadratics that are not our regular basic trinomial factoring. Basic trinomial factoring is when you have all three terms. I don't have all three terms if it's called incomplete. Incomplete is when some of the terms are missing. Now, a lot of times when you have stuff that looks like this, say I had x squared not equal to 0. If it equals 0, then the answers are 0 and 0. But if it's x squared equals, let's just say 80. Now I chose 80 because 80 is not a perfect square. I would square root both sides, and that would give me x is equal to plus or minus radical 80. We are going to have a little review session on simplifying radicals. Maybe you remember this. It breaks down into a 16 and a 5. 16 because it's a perfect square, so 4 radical 5. Just a little preview of some stuff that's coming. So far, we have had all answers that are rational, but you got to know that doesn't always happen. So we're starting a little slowly. We're keeping things rational, sometimes positive, sometimes negative, sometimes fractions, sometimes decimals, but all of that falls under rational numbers, okay? Rational numbers. When we get into irrational answers, we're going to have to remember how to simplify radicals. So I'll have a little review lesson on that. Okay, so today we did pages 8, 9, and 10 in our packet. Just make sure that you're taking your notes, and you can practice more of this by going to page 13. Page 13, maybe just try a few of them. Eventually, you're going to have to do all of page 13. Not assigning any homework today because we're going to try to Zoom meet with you guys to just make sure that everyone's okay and keeping up with their work. Thanks for joining me, and I hope that you have a great day. Bye.